now that we understand the properties of a normal probability distribution, we understand how to calculate z-values and how to read a z-distribution table. I want to bring that together and start to calculate some of these probabilities with a normal probability distribution. To do that, what I want to do is use some data. It's actually tied to a question that is in our OER textbook. Basically, it starts off saying the heights of the 430 NBA players listed on team rosters at the start of the 2005-2006 season. The heights of these basketball players have an approximate normal distribution with a mean of 79 inches and a standard deviation of 3.89 inches. So I've written that out here, just kind of the relevant given information that's in the problem for us. All right. And again, we can also look at our total population of NBA players was 430. We'll just note that as well. But now if I ask the question, we'll call this part A, and we say, what is then the probability of selecting an NBA player and having their height be between, we'll say, 79 and 84 inches? So what is the probability of a player selected at random, all right, and having their height be between 79 and 84 inches? So the question itself told us that we're following an approximate normal probability, normal distribution, the heights. We're going to label that here. Here is our average of 79 inches. We're then going to say, what is the probability of finding a value, all right, between 79 and 84? Okay, so literally we're going to go in. If we can find that area underneath the normal distribution, right? If we can find this area, all right, then we're going to know what the probability of finding a player is. So the first thing that we need to do is convert this height from literally a height into a z-value, right? So this is the height of all of the players. We're going to convert it to a z-value. Again, when we convert it to the z-value using this formula, z equals x minus the mean divided by the standard deviation, we're kind of, again, we're making that into we're kind of peeling out all of the detail associated with this, and then we're, with that equation, then going to find the corresponding standard normal value for, in this case, 84 inches. So we're going to go in, we're going to calculate our z-value for 84 inches. 84 minus 79 divided by 3.89. If we do that calculation, it tells us that our z-value ends up being right around 1.29. That's my standard normal value, all right, that corresponds to 84 inches, 1.29. Did not mention in the previous video, but let's pause for a moment and say, what's the standard normal value at the mean? 0, right? How many standard deviations away from the mean are you at the mean, right? If we put this into that formula, we'd end up at 0 every time. So this thing collapses down, and then our value, our z-value at the mean is 0. And of course, everything on this side of the mean is positive as a value for z-value, and everything on that side is negative. Again, that indicates the direction on which side of the mean that we are. So now we found the z-value to be 1.29 for the 84 inches. Now we're going to go into our table, and we can look at our z-distribution table, and we will find that 40.15% is the area underneath the normal curve. This would then tell us that we're right around a 40% chance of selecting an NBA player, all right, that's between 79 and 84 inches. Okay. If we then ask the question and said for, we'll say a part B here, what is the probability that we would select a player that is shorter than 84 inches, right? We want to find out what this is. Now what we're looking at is we're looking at everything, in this case, for part B, everything less than 84. Dropping the cap does not mean I'm going to re-record this video. So everything below 84 inches is what I'm referencing here. We know that this entire side of the distribution is 50%. So if we want to figure out what's below 84, we're simply going to add in the 50% plus the 40%, which is going to get us right around 90%. So right around a 90% chance of having a player now shorter than, if you will, 84 inches. All right. If we look at one last extension of this, if we said, okay, for part C now, we want to find the probability that we would randomly select a player from the NBA that is between 84 and 87 inches. So between 84 and 87 inches. Okay, I'm going to redraw this picture because it's getting a little busy over here. So if I look at part C, I'm going to move this over this way a bit. I've got the same, again, approximate normal distribution for NBA players. The mean is equal to 79. We have this value of x equal to 84. It had a corresponding z-value of 1.29. Now we're going to take another value of x. In this case, it's going to be 87. All right? And we need to figure out what that z-value is, because eventually what we're looking for is just this piece in here from 84 to 87. All right? What we're going to do then is we already know what this part is, if you will, from 79 to 84. We know that that area is 0.4015. Now we're going to find out what this area is all the way from 79 to 87. And what I can do is remove this part from 79 to 84 from the entire area from 79 to 87, and I'll have what I'm looking for down here in our question, which is just this slice that I shaded right there. So if we want to calculate then a z-value we've got to calculate a z-value for 87. So we're going to say we've got a z-value here for 87. Now I've got 87 minus 79 divided by 3.89. This tells us that our z-value is right around 2.06. 2.06. Then we can use that information on use our standard normal values, our standard normal tables, and it's going to tell us what the area is in a normal curve from 79 to 87. That number ends up being right around 4803, 0.4803. So when I remove the 40.15 from the 48.03, the part that I have left over is going to end up being right around 788. Or somewhere around 8%. Okay? Somewhere around 8% then would be the probability of selecting a player between 84 and 87 inches. So, ran out of room. So I'd love to do some more examples. We will, but one of our primary takeaways to this example is saying that we are going to convert from these different specific heights into a standard normal value, but one thing we have to bear in mind is we are always working away from the mean. So even in a case like this where we were looking for 84 to 87, right? I still had to go in, and any of the values that I use with my tables are going to be my area from the mean out somewhere. These pictures then become these kind of schematics. These pictures become very helpful because, again, all of the hard calculation is being done in the table, if you will, or the person that developed the table. I'm not saying these aren't challenging questions, but the challenge then becomes, where am I specifically, which part of my distribution am I working on, right? And that's exactly what these kinds of tables will start to tell us. The next video, I'm going to look at how we can find and leverage the inverse relationship that exists within these tables. If we want to find different areas, if we're given an area and we want to work backwards to a specific value.